Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's prove this derivative for secant function. The derivative of secant x is one of the two trigonometric functions where derivative will have a product of two other functions. We have here the derivative of secant x is identified as the product of secant x and tangent x. And by the way, since this is multiplication, just like that, you could always interchange whether you write tangent x first before secant x because multiplication is commutative. Now, we need to show the truth value of this using a proof. But first, let us deal with the proper way of proving this. We will no longer use the definition, but instead, we will look into the relationship of secant x to cosine. Because if f of x is secant x, this could be interpreted as 1 over cosine x, or it's the reciprocal of cosine x. With this in mind, we can use this idea to show the given differentiation rule. Now, even if the numerator is just 1 and any constant, I would like to use here the quotient rule. The quotient rule tells us that if we have a certain rational expression expressed in this form, or a quotient of two functions where our denominator is not equal to 0, its first derivative will follow this format. We shall start with the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. These terms cannot be interchanged because they are under subtraction all over the square of whatever is in your denominator. Again, let me use this even if the numerator for cosine for the representation for secant x in terms of cosine is just 1. Okay? So with this, I would like to say that k of x being a numerator is just equal to 1. Hence, its first derivative, the derivative or the rule for differentiating a constant we have here is 0. Okay? How about your m of x, which is identified as cosine x? Its first derivative is identified as negative sine x. Okay, that's the rule for differentiating cosine x. Now this time, we'll be using all of this as we show the proof here for this relationship. Let us have f prime of x using this rule, the quotient rule, denominator cosine x times the derivative of your numerator, which is 0. Okay, and then minus, of course it's minus, your numerator, which is 1, times the derivative of your denominator, which is negative sine x, all over the square of your denominator cosine. Sorry, let me place the square here. Okay, just like that. Okay, so simply continue this. This would be equal to cosine x times 0. Take note, it's the entire function. That's 0. Negative times negative plus sine x over cosine. Let me not place the square here because I would like to introduce a method that will allow me to return to the intended goal, this one here. Okay, so basically this is just sine x over cosine x squared. And what does this mean? If we have an exponentiation of 2, that is actually a product of 2 cosine. Okay, 2 cosine x. So let me have it here, cosine x times cosine x. Now, let me pair this and that. And of course, leaving 1 for the numerator because that's just 1 times sine x. And pair 1 to the remaining cosine x. And what would it look like? You will have here 1 over cosine x times sine x over cosine x, which will give us a result. What is 1 over cosine x, or the reciprocal of cosine x? The answer here is secant x times sine over cosine is just actually tangent x. This was the intended goal of this proof. Hence, we have shown, therefore, that the derivative of secant x using the idea of the quotient rule, at the same time the correct forms of the rules in differentiating cosine and sine, and all other aspects, is just equal to the secant x times tangent x. And by the way, I mentioned earlier they could be interchanged, because what if this is what you will be pairing? So you will be having tangent first before secant. Nevertheless, multiplication is commutative, so this is good already. This is the proof for this rule, and as we have some examples later on, we can now use this idea or this derivative for secant x. Thank you very much for watching. So what are you waiting for? Subscribe now.